Aloha! Happy holidays! For the Math 100 practice final, we have this one page of, as I like to call it, trigonology. We have 4 right triangles. I wanted to go ahead and do the solutions to these guys on a video so you guys can watch it over and over and over again. I'll do 2 on this video, and then I'll make a follow-up part 2, and we'll do 2 more. Okay, so we're going to start off with this guy. So we know an angle, 55 degrees, and we know the adjacent side, right? This is the side that's touching, so this guy is adjacent. And so this guy is the opposite, because he's opposite that angle. And this guy, of course, the long guy, he's the hypotenuse. So I'm going to go ahead and, the easiest guy to get is this angle right here, which must, with this guy, must add to 90. He's going to be 35. I don't want to write him in yet because I want you to realize that all these calculations we do before are going to be based on this angle. Okay, I'll write him in at the end. So first thing I'm going to go for is I'm going to go for the opposite. In order to get the opposite, I can use this TOA idea from the Sakatoa. The TOA says that the tangent of theta is equal to the opposite over the adjacent. And so we're interested in, we already got the adjacent, so we're interested in the opposite. So if I multiply through both sides by the adjacent, I go ahead and do it. Times adjacent, times adjacent. Then I get the opposite is equal to the adjacent times tangent of theta. And so that's going to be equal to 3 times the tangent of 55 degrees. That's the opposite. And so we get out the trusty calculator. 335. So I get 4.28 for this guy. So the opposite is equal to 4.28. This guy right here. So the last thing we need to get is the hypotenuse. I'm going to do it the easy way. So we know that, Pythagorean theorem says a squared plus b squared equals c squared. C is the big guy. He's always the hypotenuse. So if I'm gonna use that equation and solve for c. So c is equal to a squared plus b squared square root, and so a is 3 and b is this 4.28. I wrote it down as 4.28, but I'm going to keep it on my calculator, because on your calculator you got a bunch of digits there, so you won't have any rounding error. So I take what's on my calculator and square it. If I can figure out where that button is. There we go. Add it to 3 squared. Take the square root, and I get C is 5.23. And remember, in the a squared plus b squared equals c squared, the c guy is always the big guy. He's the hypotenuse. So we got 5.23. Okay, so that guy, and that guy are the answers to the first triangle. Okay, so that's 1 down. Let's knock out this guy next. So erase all this stuff. For the fields we go. Yeah, that's a Christmas song, right? Okay, so we got the 9.20. He's the hypotenuse, right? He's the big guy, the long guy. So 20 degrees right here. This is the right angle. This got to be 70 because this angle and the 20 have to add up to 90. So I know he's 70. Once again, I won't write it in yet. I want you to know that we're going to be talking about the 20 degrees, because in terms of the 20 degrees, this guy is the adjacent side and this guy is the opposite side. Okay. So who do I want to get first? I'll go for the opposite first. So the opposite, so we know the hypotenuse. So we want the thing that has the opposite and the hypotenuse in it. That's the SOH. S-O-H. Because remember, the SOH says the sine of theta equals the opposite over the hypotenuse. And so we want to solve for the opposite. So we multiply through both sides by the hypotenuse. And that'll cancel that guy. And so we get the opposite is equal to the hypotenuse times the sine of theta. Okay. So the opposite is equal to 9.20 times the sine of 20 degrees. Okay. Similarly, almost the exact same thing, except now we try to do the adjacent. We'll use the CA. CA says that the cosine of theta is equal to the adjacent over the hypotenuse. Therefore, if we multiply through both sides by the hypotenuse, we get that the adjacent is equal to the hypotenuse times the cosine of theta. And so the adjacent is equal to 9.20 times the cosine, 20 degrees. I haven't calculated the opposite yet. They're both so similar, I did them, just knocked them out. Now we'll go ahead and calculate these guys. So the opposite is 9.20 times the sine of 20. 3.15. Well, by the way, you can kind of check on these guys. The triangles on the picture are drawn to scale. So this is about 20 degrees. So you can see the opposite guy is small, 3.15 compared to the 9. So you can believe that this is 3 compared to that guy's 9. And when you go look at the adjacent, you're going to expect, if you had to guess, we'll ask the camera person, if you had to guess what the adjacent was, just roughly, what would you say the adjacent was?
Close to 9.
Close to 9, yeah. So, good guess, right? Because this guy is about the same size as that guy.
Mm-hmm.
It's going to be real close to 9, I would bet. Okay, so the adjacent is, get out the calculator. We got 9.20 times cosine 20. Woo, 8.64, which is very close to 9. So adjacent is 8.64. So this guy is 8.64. This guy is 3.15. You look at the picture, should make good sense. And now I'll go ahead and write this angle. The angle here is 70 degrees because the three angles always have to add up to 180. If you have a right triangle, that guy's 90, so now the other two have to add up to 90. Okay, so that's the first two. We'll stop the video here and we'll come back and do the next two in a second. Cut.